Welcome to the National Center on Response to Intervention webinar. Today we're going to be talking about making sound RTI decisions, and we're going to be talking about who responds to secondary prevention, which is sometimes referred to as Tier 2. So like I said, in this session, we're focusing on RTI, which is a multi-level prevention system. Today, I'll be referring to the first two levels of the prevention system. The first level is primary prevention, where the classroom teacher delivers the classroom instructional program while implementing adaptations and accommodations to address individual student needs. At-risk students also receive secondary prevention. And in most RTI models, secondary prevention occurs in the form of small group tutoring. One key decision point within RTI is to determine which students do and do not respond to secondary prevention. In making these decisions, we want to be as sure as possible that the children we designate as responders will in fact thrive in the general education program after tutoring ends. And we also want to be as sure as possible that the students who are designated as non-responders in fact do really require ongoing and more intensive intervention to support their adequate learning. In this webinar, I'm going to discuss what research can tell us about methods for distinguishing responders from non-responders. So why is it important to quantify response using valid decision rules? Well, the first reason is that in many RTI systems, some students linger in secondary prevention. This lingering in secondary prevention is not legal, as discussed in a U.S. Department of Education's memo on January 21st, 2011. In that memo, Melody Musgrove stated that an RTI process cannot be used to delay or deny an evaluation for eligibility under IDEA. She spoke about how students with disabilities must be identified in a timely manner. And the thrust of the memo was that long-term secondary prevention cannot be used as an alternative for providing services without an IEP to a student with a disability. It's also ineffective for students to linger in secondary prevention. If a student has not responded to secondary prevention within a reasonable amount of time, in all likelihood, they do require more intensive intervention. Some students return to primary prevention and do not do well there and therefore need to return to secondary intervention, return to tutoring again, because decisions have been incorrect about the fact that they are responders. In fact, they are not responders, and they emerge again as requiring secondary prevention. And we want, to the extent possible, to avoid this ping-ponging back and forth between primary and secondary prevention with accurate, valid decision rules for determining who is and is not responding. Another reason why it's important to quantify response using valid decision rules is that research shows us that different methods and measures for designating response produce different decisions about who returns to general education versus who moves on to more intensive intervention. And in a related way, some methods and measures provide a more valid basis than others for making these decisions. So let's talk for a few minutes about what some options are for distinguishing responders from non-responders. One popular method for designating response is to use a student's final status after tutoring ends. And often, final adequate status is defined in terms of a normative framework, and a popular criterion for designating response is that the student perform above the 25th percentile, which is a standard score of 90. In some measurement systems, it's also possible to define final status at the end of tutoring in terms of a benchmark or a criterion that is associated with future success on an important outcome. Now, a potential problem of using final status, post-tutoring status, is that it indexes final status but fails to reflect learning. And so it's possible that some students with decent final status may show worse growth than other students who do not have adequate final status. So some people argue for a dual criterion that not only considers final status at the end of tutoring, but also the amount of growth that a student has manifested over the course of tutoring. Now, some people just use slope of improvement during tutoring. And often this is defined in terms of the weekly rate of improvement based on a progress monitoring measure, so that we're using one progress monitoring probe per week or two probes every 2 weeks. And we usually have an assessment method, a progress monitoring method, that gives us a normative cut point that tells us what an adequate rate of improvement is for that measure. Now, in this situation, we have a good index of learning, but it doesn't tell us any information about whether the student's final post-tutoring status is adequate. And some students with poor slope may, in fact, show good final status. So that brings us to the next slide, where some people recommend focusing on a combination of final status and slope. And so we define response as adequate slope plus strong performance on the average of the last two progress monitoring scores. And these cut points for slope and for final status on the progress monitoring measure are usually set normatively, so in terms of a representative sample of students at that grade level. And in this case, we index learning as well as final status. And in most systems, if either final learning or final status is met, then response is considered to be adequate. Now, whatever you decide to use in terms of the measure and the method that you apply to that measure, that is, once you've picked a measure, are you going to use final status? Are you going to use slope of improvement? Or are you going to consider a combination of slope and final status? Each method you select or you consider very well may produce different decisions about which students are responsive and which students are not responsive. And for each method, the assessment tool also makes a difference. So in sum, different methods and measures will result in different groups of students being designated as responsive versus unresponsive. Some methods and measures will produce groups that are more valid for distinguishing students with and without severe learning deficits on important external criteria at the end of tutoring. Different methods and measures will also produce groups that are more valid than others for distinguishing which students will go on to develop serious difficulty in the later grades. And some methods and measures will produce groups that give us a more realistic prevalence of students who do have serious learning problems. So let's look at a little bit of data. I'll briefly share with you two illustrative studies, one in reading and one in math. Here we see an overview of a study that Doug Fuchs and colleagues conducted, where methods for designating response were contrasted in terms of how well they corresponded with later reading disability status. So 252 at-risk first graders received 10 weeks of small group tutoring. This tutoring was conducted in first grade, but then the students were followed to the end of second grade. Now, at the end of tutoring, the researchers designated responsive versus unresponsive students. And then we looked to see how the options for distinguishing responders from non-responders compared in terms of the prevalence of unresponsiveness, the accuracy of distinguishing reading disability from students who turned out not to have reading disability at the end of second grade a year later after tutoring ended, and also how the methods for distinguishing response versus non-response compared in terms of the severity of students' learning problems at the end of second grade. So did the unresponsive students, how severe were their deficits compared to the students who had been designated as responsive? So here we see a few of the different options that were considered in Doug Fuchs's 2008 paper. And so what you see if you look over to the last column is that, well, we're contrasting four different methods on this slide. So there's final normalization. So one method for designating responsive versus unresponsive students involved taking the students at the end of tutoring in first grade and looking at the Woodcock Word ID measure and taking students who were above the 25th percentile on that measure and calling them responsive, and the students who were below the 25th percentile were called unresponsive. So we looked to see how well that method for designating response worked in terms of the percentage of students who were designated unresponsive. You see that a very small percentage of students were designated unresponsive based on the Woodcock Word ID, only a little more than 2% of the general population. If we look at sensitivity and specificity with respect to end of second grade reading disability status, we see that that method for designating response at the end of first grade identified students who turned out later to be reading disabled. But in terms of specificity, it designated many more students who were actually turned out to be okay at the end of second grade and erroneously designated those students as unresponsive. So using the Woodcock Word ID measure in combination with a cut point of the 25th percentile at the end of tutoring, we would have put many students into tertiary prevention when, in fact, those students looked fine at the end of second grade. Now, if we look at CTOP, sight word efficiency, the comprehensive test of phonological processing, sight word efficiency, and again, we're using a cut point of above or below the 25th percentile to designate responsive versus unresponsive, we see that using sight word efficiency, we do much better in terms of a realistic prevalence for unresponsiveness, which is about 5%. And in terms of the designation of responsive and unresponsive at the end of first grade, aligning with how students looked in terms of reading disability at the end of second grade, we see that sight word efficiency does better than Word ID because it's being pretty good at being sensitive to when students are in fact reading disabled at the end of second grade. At the same time, it's doing a pretty good job of being specific about who turns out to have a reading disability. That is, it's not giving us a large number of false alarms. Students who are being designated unresponsive, probably put into tertiary prevention, even though they would have done fine at the end of second grade without that tertiary prevention. Now, in the same way, if you look at the numbers for word identification fluency slope and word identification slope plus final status, that's the dual discrepancy criterion, you see that both of those ways of indexing responsiveness, designating responsiveness, also do very nicely as the sight word efficiency measure does, better than Woodcock word ID measure. So if you go to that paper, you will be able to look to see how these, as well as many other methods for designating responsive versus unresponsive, compare in terms of the prevalence of unresponsiveness, how well those measures and procedures for designating unresponsiveness correspond to reading disability status a year later after tutoring ends. And also that last column shows how severe, is an index of how severe the responsive students' reading deficits at the end of second grade were compared to the reading deficits of students who were designated as responsive at the end of first grade. So here's an example of a math study also conducted at first grade. 127 at-risk first graders were randomly assigned to a control group in which they did not receive tutoring or to receive 16 weeks of small group tutoring. We progress monitored these students weekly using a curriculum-based measurement computation measure, and then we compared options for quantifying responsiveness to tutoring. So options for designating responsive versus unresponsive students when tutoring ended. So two broad conclusions about math options at first grade are these. For final status at the end of tutoring, achievement measures with a very thorough sampling of the skills that are taught at first grade level may produce sound decisions about who does and does not respond to intervention. That concerns what kind of measures do we want to use in math at first grade. We want to use measures that comprehensively sample the kinds of skills that are taught at first grade. Then we have to apply a method to those measures for designating response. And based on this study, final low achievement on first grade curriculum-based measurement concepts and applications produced sound, valid decisions for distinguishing students who did and did not respond to the first grade tutoring, as did a dual discrepancy, that is slope plus final status, on CBM computation. So let's take a closer look at progress monitoring with CBM computation to figure out methods, gain more insight into how we might want to think about designating students as responsive versus unresponsive. So in this same study, classroom teachers administered CBM computation each week for 27 weeks. And those CBM computation tests each week were administered to at-risk as well as not at-risk students. Then, a year after tutoring ended, at the end of second grade, we sorted the children into those who did and did not have a math disability. And we defined MD, math disability, as performing below the 15th percentile across computation and word problems. Now, among students who had failed the first grade screen on CBM computation, a higher proportion of at-risk students without tutoring were, in fact, MD at the end of second grade, as we might expect if the tutoring program is effective. But the question here is, how well does CBM computation initial level, that is, the first grade screen, and the CBM computation slope of improvement, that is, those 27 progress monitoring tests that we collected over the course of first grade, how does screening and progress monitoring forecast MD versus not MD at the end of second grade? So what you see here are students who all passed the screen. These are students who are, based on the screening, not at risk for poor performance when they begin first grade. And you can see that we have a higher and a lower growing group of students, but all of these students are having very nice growth trajectories over the course of first grade. They're progressing well. And so if they pass the screen, the progress monitoring data do not really add very much information. We don't need to really progress monitor those students. If they pass the screen, then they do fine. And essentially none of them end up at the end of second grade with a math disability. If you look at these blue lines, what you see are students who failed the first grade screen. They were our at-risk students in this study. And this is the group of students. These two lines include the students who were randomly assigned to participate in the control group. And we have two different distinct patterns of development on the progress monitoring data for these students, none of whom received tutoring. We have a small group of students, 16 students, who actually, despite their low screening score at the beginning of first grade, developed nicely during first grade. That's in the blue solid line. But then we have a larger group of 46 students who failed the screen at the beginning of first grade and, in fact, developed inadequately during first grade. And by the end of second grade, a very high proportion of students in that dotted line turn out to have a math disability. Now, we have two lines like that. These are the green lines for the at-risk students who began the study low. All those students failed the screen, all the green and all the blue. But these students in green, they actually received tutoring. And what we see is a nice, strong, solid green line, which indicates good development. Now, these are the tutored students, and it's a very big group of students. 47 out of 61 are developing nicely in first grade. But the green dotted line, there is a small group of students who receive tutoring, 14 out of 61, who have inadequate progress monitoring data. Their trajectory of development does not look good. And at the end of second grade, a large number of those 14 students who progressed poorly despite tutoring end up having a math disability at the end of second grade. So there are some take-home points from these 6 trajectories of development over the course of first grade. The first take-home message is that students who pass the initial CBM computation screen do not turn out to have a math disability at the end of second grade. Students who pass the screen, if it's a good cut point, therefore do not require progress monitoring. We have enough information just knowing that they pass the screen. And their math development, at least through the end of second grade, is strong. The problem is that when students fail the screen, the screening score alone is not accurate for predicting math disability status at the end of second grade. So if we look back at our slide, we have 4 groups, all the blue and all the green lines. They all failed the screen. And their screening data alone does not tell us how well they're going to develop over the course of first grade. Instead, we need the progress monitoring data, those 27 data points, to be able to model their first grade math development. And their first grade math development then corresponds well with how they look in terms of MD status at the end of second grade. And so students below the screening cut point require progress monitoring. Some of those students will progress nicely and others will not. And this is true whether or not they receive tutoring. So CBM computation progress monitoring is useful for distinguishing which students will and will not have severe forms of math difficulty at the end of second grade. So across reading and math, to distinguish responders from non-responders, the method, are you using final status? Are you using slope of improvement? The method makes a difference in how sound your decisions about responsiveness versus unresponsiveness will be. Assessment tool also makes a difference. So we need to select a method and an assessment tool carefully to understand how accurate that method and tool will be for identifying students who in the long term can be expected to fare well in general education. We want those students to accurately be designated as responsive to secondary prevention. And we need to select a method and assessment tool that also accurately identifies for us students who will not fare well unless they receive more intensive tertiary prevention. Now, one source that's really great for giving us information about what tools to consider is to go to the National Center on RTI's Progress Monitoring Tools Chart. So the NCRTI has 3 different tools charts. One of those tools charts is on progress monitoring. And from going to that website, we can learn information about what method various tools recommend for quantifying response when you're using their tool, and how good the research data are to support the recommendation for the method that the tool employs for designating responsive versus unresponsiveness. If we go, for example, to the Technical Review Committee for the National Center on RTI requires vendors to specify standards for minimal acceptable growth when we're progress monitoring students. This serves as one potential method for designating responsive versus unresponsive students. So the question that's being asked is minimum acceptable growth well specified for that tool? And the growth standards can be norm referenced or they can be criterion referenced. So let's look at a few examples from the progress monitoring tools chart for the National Center on RTI. Here we see information on a tool, curriculum-based measurement, letter sound fluency at kindergarten. And that tool has a recommendation for how users can determine response. If you look at the third and the fourth column on this slide, you see that to determine response, the vendor for that tool, based on research data that they have, is recommending that post-tutoring status should be at least 30 letter sounds correct in a minute, and the slope of improvement over the course of tutoring should be an improvement of at least 1 letter sound per week. That slope of improvement of 1.0. So the Technical Review Committee looked at that tool and looked at the recommendations that the tool provides for designating responsiveness, and the Technical Review Committee found that recommendation to be convincing based on the data that the vendor provided to support that recommendation. Here's another example. We have a STEEP measure, and here we have recommended weekly rates of improvement at grades 1 through 5. So the measure STEEP, the vendors of that measure, submitted the tool to the Technical Review Committee. They provided these recommendations for determining adequate weekly rates of improvement for designating responsive versus unresponsive students. And they provided their research data to support their recommendations for weekly improvement. And here again, the Technical Review Committee found those recommendations for the STEEP tool to be convincing. And here we see a third example, the STAR early literacy measures. Here we have growth expectations, like slopes of improvement. And here the vendor is providing slopes for students who are below the 20th percentile and for students who are at the 50th percentile. The STAR people provided research documentation to support these recommendations, and the Technical Review Committee, again, rated these recommendations and the data supporting the recommendations to be convincing. So if you go to the tools chart on progress monitoring, you can look at a lot of different kinds of information, including rates of improvement, which is the fourth column toward the end of the chart, rates of improvement specified. And if you see a solid dot, it tells you that the Technical Review Committee found that tool's recommendation to be convincing. But if you see a half full or an open dot, then the Technical Review Committee did not find the recommendations to be convincing. And you can look down any of the columns for different kinds of information that the Technical Review Committee judges to see how well the tool fared. So here you see AimsWeb, and you can look down the chart to see curriculum-based measurement in the area of reading. Dibbles measures are on the chart, a measure called Easy CBM, M-Class, monitoring basic skills progress, some Orchard software products, a product by Scholastic, and then the STAR and STEEP measures were all evaluated by the Technical Review Committee, and you can get lots of good information from the tools chart, including methods for designating responsive versus unresponsive students. So that gives you a little bit of information about how we think of responsiveness versus unresponsiveness. At the end of secondary prevention, at the end of tutoring, schools are faced with making the decision: who has been responsive to this tutoring? Who goes back to general education with the assumption that they will do well there? And which group of students has responded to tutoring inadequately such that we designate those students as unresponsive, and because of that, we move those students into a more intensive form of intervention. So we've talked today about how to think from a measurement perspective about what measures to use and what methods to apply to the data that are derived from those measures for designating responsive versus unresponsive students. And if you're interested in getting more information about the National Center on RTI, you see the link, the website on this slide, and then you can navigate to the progress monitoring tools chart that I've talked a little bit about on the center's website, and you see also the link on this slide. And if you have any questions, you can email them to rtiwebinars@air.org. So thank you.